We have seen the previous concept of AR/VR, and now let's talk about another amazing and futuristic technology known as 3D printing. Imagine a world where spare parts for machinery, customized tools, or even medical devices can be produced instantly at the point of need. This is exactly what 3D printing brings to the table. A real-life example can be seen in the automotive industry, where companies like BMW and Tesla are using 3D printing to produce customized components for their vehicles, reducing lead time and inventory requirements significantly. 3D printing, also called additive manufacturing, is a way to make physical objects directly from digital designs. Instead of cutting or molding materials, the printer builds the object layer by layer. Think of it like stacking very thin layers of clay or paper to gradually create a full sculpture. For example, in a factory, if a spare part for a machine breaks, instead of waiting weeks for a supplier to deliver it, engineers can print the part on site using a 3D printer. Similarly, in a toy company, custom toys or prototypes can be made quickly without creating molds. So 3D printing allows fast, flexible, and cost-effective production directly from digital designs, saving time and resources. The technology was first conceptualized in the 1980s, but only in recent years has it become widely accessible and practical for industrial use. To understand how it works, let's take a simple example. Suppose a warehouse needs a replacement gear for a conveyor system. First, an engineer creates a digital 3D model of the gear. Next, the model is sent to a 3D printer that uses materials like plastic, resin, or metal powder. The printer then adds material layer by layer, following the digital design until the gear is complete. Finally, the printed gear is tested and installed, ready to function without the usual wait for supplier delivery. Now we will talk about the uses of 3D printing. Our first use is for spare parts production. Companies can print components on demand, reducing the need for large inventories and minimizing storage costs. Our next type is custom manufacturing, which allows businesses to produce personalized items or prototypes quickly. For example, a manufacturer can create a custom-fit part for a high-performance machine without redesigning the entire assembly line. Another use is in supply chain resilience. By producing critical items locally using 3D printing, businesses can reduce dependence on long and uncertain global supply chains, which is especially valuable during disruptions like natural disasters or pandemics. A top real case study is that of GE Aviation. Previously, the company faced long lead times and high costs for producing certain aircraft engine components. Around 2015, GE implemented 3D printing for specific fuel nozzles and complex parts. By adopting additive manufacturing, they reduced production time from several weeks to just days and cut part weight by 25%, improving fuel efficiency. GE reported significant cost savings, faster delivery, and enhanced design flexibility, highlighting the transformative power of 3D printing in modern supply chains. So we simply seen how 3D printing is not just a technological innovation, but a game changer for supply chains, warehousing, and manufacturing. It enables faster production, reduced inventory, and more customized solutions. In a nutshell, 3D printing allows businesses to rethink traditional manufacturing processes, making operations more agile, efficient, and responsive to real-world demands. Hopefully, you found this concept exciting. Now, very important topic we discussed, and that's amazing learning I believe you have today.